Hello everyone and welcome to P Academy. So in this video we are going to be looking at the concept of sets. So if you are new here, please kindly click on that subscribe button and hello everyone and welcome to P Academy. So in this video we are going to be looking at the concept of sets. So I'm going to be covering everything that you need to know about sets. So to start with, let's look at what the definition of set is itself. So you can say that set is a collection of well-defined objects. So set is a collection of well-defined objects. Alright, so I hope this definition is clear, and if it's not, let's just continue and as time goes on. And before the end of this video, you get what I'm talking about. Alright, so now what I want us to look at is some of the terms and the notations. Terms and notation used in sets. So if you come across any question on that set, there are some certain terms that you definitely need to come across and you need to know so that you can answer questions on that set. I hope you're following. So the first one I want to mention is elements. So when we talk about elements, that is you can define it as members of a set are called elements. All right, so let's look at this example now. So if you have a set A, and you have your parentheses, and you have A, B, C. Now the element of this set A is this A, B, and C. So that's what we refer to as elements. And don't forget, when you are trying to write a set and you put maybe set A, don't forget this parenthesis should always be there. So this for set A now, if you had called the element in set A, we have A, B, C. Exactly. So let's look at B now. If you look at B, let's say you have a set B like this 1, 2, 3. So the element of set B are what? 1, 2, 3. I hope that is clear. Alright, so let's look at another term. So this is a notation. If you see something like this, it's looking like E, but it's not. So what this notation actually means is an element of or belong to So when you see this notation, it's just a short form of saying is an element of or belong to. I hope exactly. So for example, if you have something like this, that's B, and then you have the notation, and then you have A. So if you have to call it, you say B is an element of A. Now looking at this example that I have here, the B is part of the element of A, like I've just said. But if you want to represent it using the set notation, you're just going to write B, then the notation, and then A. That means B is an element of A. I hope that is clear. Alright, so let's look at the opposite of it. This is also a notation. So if you have something like this, and you have a something that is crossing it like this, a forward slash crossing it. So this simply means is not an element of. So that's the meaning of this notation. Or you can just say does not belong to. Does not belong to. So it's just the opposite of what we are having in this number 2. I hope that is clear. So for example now, if I'm to use what I'm having here, I can say 3 is not an element of A. So if you look at set A now, 3 is not there. 3 is an element of B, not A. So this is the notation that you can use to express it. Alright, so now let's go to number 4. Alright, so for number 4, if you have this notation, n into brackets A. Now, this A could be any alphabet. Exactly, it could be anything. So, what this notation actually means is number of elements in set A. Exactly. So, now let's come back to this what I have here. So, if you're looking at this set A, we have 1, 2, 3. There are 3 elements here. If you look at set B also, we have 1, 2, 3, 3 elements. So if you have to represent that using this, when you see n in, then the name of the set is what is in brackets. So for example, this is now, if you have the number of elements in set A, so we just say equals to 3. Exactly. So you just count the elements 1, 2, 3. This one too is 1, 2, 3. So it can be 4, it can be any number it adds. So that's the meaning. It's just a way of asking that what is the total number of elements in that particular set. Alright, so let's look at number 5. So don't forget we are still looking at the terms and the notation that are used in set. And if you are finding value in this video, please kindly give it a thumbs up. Alright, so let's look at number 5. We have an empty set. So we call it empty set or null set. So, and the symbol or the notation for that is you just have a parenthesis like this. It should be empty or exactly. So this is how it will look like. It's an empty set. So if you have a, let's say we have, for example, let's say we have A equals to. So that means it is an empty set. That means set A doesn't have any elements. Exactly. Or you can just say A equals to this. So that's a notation for an empty set or a null set. Alright, let's go to number 6. So number 6, what I want to look at now is the universal set. So universal set. Alright, so what do we call a universal set? So first of all, let's look at the symbol. It's always symbol is like this, or you can look at something like this. Exactly. So it's either having a kind of E like this or a kind of U that looks like this. Alright, so if you are to define it, you said I want this is a set that contains all the elements. So what it means is that if you have a universal set, it is a set that has all the elements of any other subsets that are under it. So this is what I'm talking about. So if we have a set like this, let's say set A. Okay, set A. Or let's use this one that we are having at the top. This is a set A and set B. So if you are to have a universal set, for example, so universal set will have all the elements exactly so both set A and set B and every other set that is under it. I hope that is clear. Alright, so that's for number 6. Now let's look at number 7. Number 7, we call it a subset. A subset. So when we say something is a subset, when we call a set a subset, it says it is a part It is a part, or let's say a fraction of the universal set. Or is a part or a fraction of the universal set. Alright. Of the universal set or another set. So let me just add this. So let me explain now. So let's say we have a universal set like this. A universal set, and the element in that set is 1, 2, 3, 4, and then up to 9. So this is another thing you have to note. If you have a number that is following the same sequence, like 1, 2, 3, 4, 5, and then you have this dot 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 dot, and I get to 9. So this dot 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 dot, I'm having this dash 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 means 5, 6, 7, 8 exactly. Alright, so if you have a universal set like this, and then you have another set A, and then you have the following elements 2, 3, 4, 5, and then you have another set B, and then you have the elements like 1, 2, 9, and so on. So we can say that A is a subset of the universal set. Exactly. A is a subset of the universal set because all the element that is in A, you can find it in the universal set. Exactly. It might not even be a universal set. The set can be, let's say, you can call this a set C. So that means A is also a subset of set C. So that's why I say it is a part or fraction of the universal set or another set. Exactly. So in a case where it is not the universal set but another set, as long as all the elements in this particular set are in the main set, so we say that it is what? It is a subset. Alright. And then the symbol that we use to represent it is something like this. It looks like this. Exactly. It's not really a C, but that is how it looks like. Exactly. So this is how the shape looks like. So if I'm to put this using the notation, I'm going to say A is a subset of C now. Or if it's a universal set, I'll say that A is a subset of the universal set. I hope that makes sense. Alright, so let's look at number 8. So in number 8, we're going to be looking at union. So this is another term that we use in sets, and the notation or the symbol is like this, like a U. Exactly. But it won't have those ones that will come down this downward stroke. Alright, so when we talk about union, it's just, so you can say it's a combination. So union is just a combination of all the elements in two or more sets. Exactly. And there's one thing you also have to notice, that, let me put that in brackets, is that no repetition. No repetition of elements when you are considering the union of a set. Alright, so let's look at an example. So if you have a set A with the following elements, and the element in that set A is A, B, and C, and then you have another another set B with the following elements B, C, D, E. Now these are two sets already, A and B, and we are asked to look for the union. So this is how it will look like. So that means maybe if in a question you are asked to look for union, A union B, so that will be A union B. So this is how it will look like. So in answering such question, we are going to be having, like I said, combination of all elements in two or more sets. Note there will be no repetition. So let's look at that of A. We have A, the element in set A, B, C. That of set B, we also add it together. Now you can see that there's B here and there's also B. There is C and there's also C. So there's no need to writing it out again because we've already write it when looking at the union. So we add D, E, and then we close it. So the union of A and B will give us A, B, C, D, E. So that's what we mean by union. So note that when you are considering two or more sets and you are looking for the union, you don't repeat any set, any elements. And so you don't say because we have A here, or rather we have B here, we have B here, then B will appear 2 times here. No, just one is that you use. Alright, so let's look at another one that just looks similar. So they call it that's the number 9. So we call that one intersection. So intersection. So intersection, it has this symbol exactly like N, but don't forget it won't have that stroke that will come up, just a curve like this, like N. So for intersection, that is so you can call it a combination of elements similar to both sets. Similar to both sets. Exactly. So now let's consider this set A and set B. So if you have a question and you're asked to look for A intersection B, so you can see this is how when you have a notation like this, that means A intersection B. Exactly. This one is A union B. So if you have a question like A intersection B, that is intersection of set A and set B. So what will it be if you are considering this set A and set B with these elements? So that means the element that is similar to or that is common. So let me change this word to common. Exactly. That is common to both sets. So what do we have in both sets A and set B? So if you look at it closely, we only have B and C is here. B is here, C is here. We have B here, we have C here. So that means the intersection A intersection B will be what? B and C. So these are the only element that is common to both A and B. Exactly. Now, if for any reason you are given any question and there is nothing common to the two sets you are considering, that you are putting into consideration, so it's very simple. Let's say the set is, you are looking at set X intersection Y. And when you look at it, and maybe we have set X, for example, and we have the elements in set A to be 2, 4, 6. And then we have the elements in set Y to be, let's say, 7, 8, 9. So now you can see that they have nothing in common. So since they have nothing in common, if you are to look for X intersection Y, it will be a what? It will be an empty set. So you can, and don't forget the notation for empty set is like this. Or you can just say X intersection Y is what? Is an empty set. There is nothing in common. Exactly. All right. So we've been able to look at 9 notations or terms that are used in sets. So this is just like the basic. I cover some of the basic of sets. So in the next video, we are going to be looking at how to solve questions under sets. Exactly. So that's what we're going to look at in the next video. I'll leave a link to that video in the description. We are going to be looking at how to use some of all these terms in answering questions. So if you find value in this video, please give it a thumbs up. If you are yet to subscribe to this channel, kindly click on that subscribe button. And don't forget to check our website, paacademy.co. So that's paacademy.co, not .com but .co. Exactly. So it's just one word, paacademy.co. So do make sure you check out our website and also subscribe to our channel. So thank you very much, and I'll see you all in the next part of this video.